Hey, I'm Chris Zepp from Make Everything, and today I'm taking a 9-inch disc from USA Knife Maker and a 2.5 horsepower treadmill motor that I got out of the garbage, and I'm building this variable speed, multiple position disc grinder. Check it out. Okay, so the basis of this project is this motor right here. Now this is a 2.5 horsepower motor that I got off of a treadmill that I found in the garbage. This was, I don't remember the brand of the treadmill. If I remember, I'll put it here. But anyway, I had read a long time ago that treadmill motors could be used, and obviously they have that big plastic controller for the treadmill to control the speed of the belt. And I always thought, you know, if I took these motors, eventually I'd figure out a way to get rid of that control board and run them with simpler controls. So I found a YouTuber, and his YouTube is Mike Man Made. I'll put links down in the description. He has a bunch of fantastic videos showing you how to use the controller that comes with the treadmill with a potentiometer, how to get rid of the controller and do things with other electronics. Anyway, I highly suggest you watch his videos. I'm gonna brush through how I got this motor set up, but more or less, this is the motor controller that came on the treadmill and the power supply that came on the treadmill because it has a nice 15 amp fuse. Again, it's a 2.5 horsepower DC motor, and we're gonna be able to get unlimited variable speed out of it. Let's get started. Okay, so this particular treadmill motor controller is an MC60. These are very common. You're going to see a lot of treadmills, if you pull them apart, are going to have this motor controller in them. If you have an MC60 motor controller, what you can do is you can take a linear potentiometer, and I'll have a link to this one exactly in the description of this video, and you can solder 3 leads onto it that will then lead to 3 positions on the controller itself. They say black, white, and red. They are also labeled L, W, and H. These 3 positions on this side of the MC60 controller. And with this, you can completely eliminate that big plastic controller that would normally be on a treadmill. I'm going to plug this in and you can see how it works. Okay, so I'm using the power supply box that was on the treadmill itself for now because it has a nice 15 amp fuse built into it. And I feel like since I'm kind of doing some of this electronic work myself, it would be good to have this fuse in there in case anything starts to overload. So if I flip the switch and turn it on, I get a red light on the board. Now I have the potentiometer turned counterclockwise all the way, which would be the off position. You can see the motor spindle right here. If I turn it on, it takes a minute because there's a soft start built into the controller, and now you can see the motor spinning. Now I can crank this thing all the way up and get a lot of RPMs out of it, and then I can turn it back down. And now when I turn it down all the way to the left, the motor signal light turns off, which is how I know the motor is off. Now the only thing about this, the only limitation is that there's always going to be a soft start. So I'm never going to be able to set this to a speed and flip a switch and turn it on, at least with this setup. Now for me, that's going to be fine. The disc sander that I'm making is usually going to be ran at slow speeds anyway. So I can kind of just turn this up a little bit, get it to spin, and then I could always turn it back. So having the motor running was sort of the hardest part for me. Now let's get working on building out the rest of this thing. So this is a 9-inch aluminum disc. This is made for making a disc grinder, and this came from USA Knife Maker. Now this one has a 5/8 of an inch arbor hole on it and a keyway cut in it. Now the motor shaft on this particular motor is slightly larger than 5/8, just by a hair. Now I could take this over to the lathe and I could turn it down to make it perfect, but I want to make this video and this build a little more accessible to people that maybe don't have a lathe. So we're just going to actually use the motor's rotation itself and a file, and we're just going to file this down enough so that we can get this plate on there. Okay, so I took some quick clamps and I just clamped the motor down to my metal table, and I'm grabbing a bastard file here and just filing down the shaft a little bit at a time. So the shaft measured at about 0.685 or 0.69, and I needed it to be 0.625. So I had to take about 40 thousandths off the off of the shaft, and in all honesty, I overshot it with the file. I was kind of rushing, and instead of taking smaller bites, I took a kind of a big drastic cut that last time around, and I really took off more material than I wanted to. This led to a ton of problems. I also thought I should sort of taper the end of the shaft to kind of like wiggle it on there. That was also a mistake. So don't make my mistake here. Take your time grinding down that shaft until it's perfect. Use a caliper, use a way to measure it, don't eyeball it. It would have saved me hours. Anyway, once I was done with that, I took a grinder and I ground in a flat spot so I could utilize the keyway on the disc itself. And I took a little bit of 1/4 inch by 1/4 inch flat bar and I made a small shaft key that would just sit in there and be pressed on by the Allen key set screw that was inside the disc from USA Knife Maker. I hammered on the disc because it had sort of a taper, and you can see the end of the shaft sort of sticking out there. And that's when I started to mess around with the offset and the run out. Okay, so I decided to upgrade to a vise, a little smarter, right? And what I was doing there was I was just checking the run out of this thing. I got it down to about 5 thousandths, which is pretty good. I put some shim stock in the front, but now I have to disassemble this whole thing so I can get started on the enclosure. I just basically wanted to make sure I could get everything tuned up right before I went any further. I'm gonna leave this chucked up leave this in here and cut this off. So those two little motor mounts that were originally used to adjust the belt tension on the treadmill itself, those can go. I grabbed the portaband and I just sliced those off. There's might have been a better way to do this, but again, it worked out. This quick vise that I'm using is super useful for stuff like this. It gives just enough grab that it doesn't mar anything up, but it holds your parts really sturdy. And now I'm just taking the grinder and just grinding away some of those sharp edges that I left on the motor mount. I don't want to go too crazy trying to cut it off. It's welded to the actual motor casing itself, and I don't want to mess that up. Now, in order to properly build the stand, I'm going to need some sheet metal. This is just 1/4 inch mild steel, and I measured the diameter of that little piece on the motor itself, and now it's just a matter of cutting this piece of steel in half so I can drill a hole in it to properly mount the motor to it. Sometimes the bandsaw is just not fast enough. I ground out these pieces and made them nice and square. And when I had measured that outside diameter before, it came out to be about 1.75 inches. So I'm just marking off sort of a central point on this piece of 1/4 inch steel. Now this piece of 1/4 inch is going to be 5 inches wide by 10 inches long. And I'm drilling this hole with a hole saw. This is just a regular bimetal hole saw. This one's a Milwaukee brand. You can buy these at like Home Depot, order them online. And if you run these at a slow enough speed and with a cutting oil, you can easily drill through plate like this. You just have to be gentle, let the tool do its job. Don't push it too hard, and it'll absolutely do what you're looking for. You can see how nice of a fit I get on that too, which is awesome. Now, once I have that hole drilled in there, I can mark out some holes to put some mounting screws in. Now, since that flange on the treadmill motor is pretty thin, I want to drill and put my bolts through that, and I want to thread the 1/4 inch plate that I'm using to receive the screws. I'm covering up these little motor ports with some tape just because they lead directly down into the motor, and I don't want any pieces of metal getting in there and potentially scoring up the motor or making an electrical contact somewhere that I don't want it. This is going to be covered by that steel plate, so I'm not going to have to worry about anything getting into those holes after the fact. So I can actually remove this tape once I finish drilling these holes. Once I have them drilled, I can just mark them out on the piece of 1/4-inch plate and do some center punching with that automatic center punch. I'm going to be tapping these with a 1/4-20 tap, so I'm using a number 7 drill to drill my pilot hole, and then I get to use my new tapping station that I just posted a video about last week, and I can switch over to my Supreme tapper, which has a 1/4-20 tap in it. I bring the RPMs of my tapping machine up to 1100 because this tapper actually reduces the speed internally. And I'm still trying to work out a good way to hold the vise, but for now, just sort of holding it down and letting the spring on the quill pull back on it seems to be working pretty well. See how quickly I'm able to tap those 5 holes. Now with that work done, I can go over and mount the motor to this piece of plate. The only 1/4-20 screws I had were super long, and the drill I have has a little bit of a problem with the impacting, so you're going to hear it kind of impacting as it goes through, but the threads were all really good. I really didn't have any issue there. This is going to give me a really solid attachment point, especially with this 1/4-inch plate. And once I get these screws nice and tight, this thing's really not going to go anywhere. I grab the grinder and just cut these screws off, make them nice and flush so I don't have any issues with them sticking out. These screws really don't need to be taken out ever again. Now the way that I'm going to make this into a multi-position tool is I'm going to weld another piece of plate perpendicular to it. I'm using my corner squares, my true angles from Ollie Iron. Check these things out. I just got them and I've used them on a couple projects already. They're fantastic. They've really helped me with my workflow, helped me keep things nice and square. And to complement them, I picked up a bunch of these inexpensive welding vice grips from Harbor Freight. And all in all, they've saved me a ton of time in my setup and made a lot of things a lot more precise. I'm being careful here to tack things before I weld them because I want to make sure that this thing stays square and doesn't warp. I was going to put in some gussets, but I really don't want them to be in the way of my socket system that I'm going to be doing. So I think these welds are going to be fine as long as everything cools down and doesn't warp. You can see that little indicator I have on there. That was something that was sent to me by KW Woodworks on Instagram. It's actually been a huge help. You should check out his page. He makes some incredible stuff. I'll put a link to him down in the description. Thanks again, man. I had made a little bushing and did some shimming to that disc to try and make it have as little run out as possible. Okay, so here's the issue that I'm having. I'm getting like between 5 and 10 thousandths run out in the wheel, and I've been messing with it for like an hour now. And what I'm noticing is there's a lot of flex in the wheel, so I'm thinking that the run out is actually okay. What I'm going to do is I'm going to actually put a piece of sandpaper on this and kind of try it out and see if the run out really causes a problem. This is 3M feathering adhesive. This is recommended by a couple of the other guys that use these things. Nick Wheeler is one of them, so let's give this a shot. Never actually used this before. I did a terrible job putting that feathering adhesive on, but I'll get used to it. And I lost my razor blade. Oh, there it is. And it's got super glue on it. Oh, this is just going horribly now. All right, so that's 220 grit silicon carbide on there. Let's try and flatten something. Wow, look at that finish. Now the idea here is that I can also flip this now like this. Just gonna have to figure out a better way to deal with all this other stuff. Okay, great. Now with it in its other position, I can sort of test the performance of it as a horizontal disc grinder. And again, I get really nice surface finish. I'm really happy with this, with the way, even with a 220 grit piece of sandpaper on there, I'm still getting like a near mirror finish, which is exactly what I was going for with this. I wanted a quick and easy way to make things nice and flat and maybe do some profiling on some knife scales and really just have a new tool to change the way I fabricate in the shop. So the next component to this is the actual socket that gets mounted on the table itself. Now I'm using the same piece of 1/4 inch plate, and now I'm making the socket mount plate. The dimensions on this are about 5 1/4 wide by about 7 inches long. Now I didn't want to use this whole piece of plate because I really didn't need it. When I switch positions on the disc sander itself, I only have so much material sticking out, so I just figured I would save as much of this material that I could and make this mounting plate as small as it had to be in order to perform properly. Now the trick here is going to be to mount some pieces of angle stock to the sides in a way that they won't be in the way, and that I can tap some holes in them and make sure that I can lock down the grinder. So I go over to the bandsaw and I cut about a 1/4 inch off of one of the legs of the angle stock, and that's going to allow me to get nice and tight to that 1/4 inch material. I go over to the drill press and I drill some more number 7 holes in there, and that'll allow me to take this back over to the tapping station and then tap these holes with another 1/4 20 so that I can put some thumb screws in there to lock in the grinder when I have this thing mounted in the different positions. I wound up doing 3 tapped holes here, which seemed unnecessary after the fact because I'm really only going to wind up using 1, but rather be looking at them than looking for them. I'm going to be using some aluminum flashing here, which is relatively thin and forgiving and also very cheap, and that's how I'm going to space these retaining bars that are going to keep this whole thing together and make it so that the thing will slide in and out of the socket well without getting bound up. So I have a piece of that flashing in between the plate and the angle piece, and when I remove it, it's going to give me perfect clearance to slide this thing on and off. With one side down, I can move over to the other side and do the same thing. And I'm really just being mindful to make sure that I don't weld anything together that's not supposed to be, and I'm being a little gentle with my tacks as to not make anything warp. It takes a little more effort to rip this piece of shim stock out, but once I do, you can see how nicely things slide. With the proof of concept there, I can go ahead and add a little bit more weld to this. I didn't go super crazy because I really didn't want these to warp and camber out. So the welds that I put on there are going to be strong enough to keep this thing together, but I didn't superheat the material and get anything to move around. I grab the grinder and just deburr it. Deburr these corners a little bit, make sure everything's nice and smooth and hand-friendly. And you can see the way it slides on there. Just needs a little bit of cleanup, and it'll be good to go. You can see how quickly I'm able to change positions on that, which is exactly what I was going for. Now I add in these 2 thumb screws, and you can see how quickly things tighten up. It makes it so that this thing does not move at all, which is awesome. And I might upgrade these to something with like a knurled plastic knob or something like that to make life a little bit easier. Now just to make a little box to mount the controller. Now this is a little unnecessary. You actually could make this box out of anything. You could make it out of plywood, you could not make a box at all, but I wanted to protect those components considering I'm going to be making a lot of conductive dust, grinding metal and all that. So I head into my little sheet metal area in the back of the shop, and this is some 18 gauge mild steel. I shear it up and make out my marks to build this tube. Now this is a Bailey magnetic brake. I just recently picked this up used, and this is really the application in which it shines. So basically that blue plate on the top is not held down with anything other than electromagnetic force. This thing generates 6 tons of downward electromagnetic force, and it really allows you to do things differently than you would on a normal finger or pan brake. So I'm able to basically slide this sheet metal around underneath these guide bars and switch out multiple different, pressing bars so that I can accomplish different shapes. This allows me to build a little project box that has these tabs on the top side, so when I add a lid, I can just zip screw directly into the tabs, and that'll give me a nice way to open and close and seal the box when I want things to be closed off and eliminate all the metal dust and everything from getting in there. I go back over to the shear and I shear up the sides and the top of the box, and then I can head back to the welding table and tack this whole thing up. So I actually made those tabs on the top side a little big because I wanted to have a little bit easier of a time bending them. So once I'm done with this, I actually take the grinder and I just grind out about a 1/2 inch off of those and deburr everything, make it nice. Now with the lid, I just take some zip screws and I zip them right through into those leaves, and that gives me my sort of threaded, repeatable top section that can come on and off as I please. And now it's helpful to add that top piece before I weld the sides because it'll eliminate some warping. I'm very careful here not to overheat this and burn through it. I want this to stay nice and clean. So I basically just do a series of tack welds around the perimeter of the side and make sure everything fits on my actual grinder motor setup. And then I can come back and do the other side. You see how I'm clamping them to the table too to keep them from warping. Once it's all welded up, I can go in with the grinder and just sort of clean it up, make it look a little bit nicer. Get rid of some of those ugly spot welds. Now I'm using the plate from the treadmill itself to trace out the holes that I need to cut for the controls that I'm going to be reusing. So the rectangles and the ovals I can accomplish with both the Dremel and a stepper bit. And this just allows me to perfectly know exactly how much room I need to cut out of the sheet metal to use those old controls. And I'm happy I got to recycle them. The on-off switch was still good, and that 15 amp fuse is a nice little feature in case anything gets overloaded. Like I said, this is kind of a DIY amateur wire up, so it's good to have some safety in there by the way of that fuse in case something were to overload or try to pop. It would just trip the fuse before it surged all the way back to the plug. And then my little linear potentiometer can go in there, and that'll give me a nice sturdy place for me to adjust the speed as I go. Now you can see the motor controller just fits inside there, and I use some more zip screws to zip screw it down to the back side of the box, and I take the grinder and cut those screws off. I needed to use a larger stepper bit to drill the hole for the power cord. I just reamed this thing out to the size of the strain relief that they had used on the treadmill, and then I'm able to wedge that in there, and it'll give me a nice factory looking cord coming out of this box, which I'm really happy about. Now drilling the hole for the motor power leads that come off the motor themselves. Now these don't have a strain relief, so in order to accomplish that, I actually just took some electrical tape and wrapped it heavily around the cord about where I wanted it to pass through the box, and then I wedged it into the sheet metal box to act as a strain relief and also as a dust plug to keep some of the grinding dust from going through that hole into the motor controller. Now the last step here was to mount this little control box to the plate. I tried to use some zip screws, but they didn't really work. So what I wound up doing was drilling and tapping a 1/4-20 screw and putting that in there, making it nice and tight. I know people are going to say something about how it's hanging off the back of the plate. This was the material I had, and at the end of the day, it turned out fine. Now just giving it a little speed test, making sure that everything still works, making sure that I'm getting power and that I didn't short anything out, and we're good to go. Now the final step was to just drill and countersink some holes in that mounting plate, which was pretty straightforward. I used some 1¼ inch screws to mount it to the wooden bench, and you can see how quickly and easily I'm able to change positions on this thing. Again, I added some feathering adhesive and a fresh piece of 220 grit sandpaper, and I'm able to give this thing a good test run. Overall, I'm really happy with how this thing came out. All right, that about does it for this video. I had some challenges along the way on this one. I was dealing with that run out on the disc. Kind of one of those projects where things just kept going wrong, but you know, got to be persistent. In the end, this whole action of being able to take the thing out and move it, reposition it, I'm really happy with how that came out. I think it's going to be a huge addition to the shop. I really am excited to use it. It flattens up material incredibly well. The surface finish, even with a 220 grit pad, is incredible. So anyway, thank you to Benchmark Abrasives for supplying the cutoff wheels and grinding discs that I use in the shop on a daily basis. If you're interested in building something like this and you have questions, leave them down below. Don't forget to check out the links that I put down there involving using the treadmill motor and the motor controller and stuff. All that stuff is down below. The YouTube channel that I got the information, all that stuff down below in the description. If you like this video, give it a thumbs up. If you want to share with others, please send it around the internet. I'm sure there are other knife makers who would love to take a motor from the garbage and spend about $100 to make one of these. Subscribe to my channel to see more videos like this, and don't forget to follow me on Instagram at MakeEverythingShop. I posted a ton about this. I post on my story every day when I'm working on projects and give sort of a behind-the-scenes look as to what's going on in the shop. So again, I'm Chris Epp from Make Everything. Thank you so much for watching this video, and I hope to see you on the next one.